The discovery of 3I/Atlas has reignited one of the most fascinating and controversial debates in modern astronomy. How do we interpret strange behavior in rare interstellar objects? And where should the boundary lie between open-minded scientific inquiry and extraordinary speculation? Detected by the Asteroid Terrestrial Impact Last Alert System, 3I/Atlas is only the third confirmed interstellar object ever observed passing through our solar system, following 1I/Oumuamua in 2017 and 2I/Borisov in 2019. From the moment of its detection, it stood out not merely because of its origin beyond our solar system, but because of a series of puzzling physical characteristics that appear to challenge simple explanations. Its unexpected acceleration, shifting color, and lack of obvious cometary debris have made it an object of intense scrutiny, and in some circles, bold conjecture. At the heart of the debate is the question of whether 3I/Atlas can be explained entirely by known natural processes, or whether it hints at something far more exotic. NASA and the majority of planetary scientists argue that the object is a comet, albeit an unusual one. In contrast, Harvard astrophysicist Avi Loeb, already well known for his provocative interpretation of Oumuamua, has suggested that the anomalies associated with 3I/Atlas could, in principle, be consistent with technological activity, even going so far as to speculate about an alien engine. While Loeb is careful to frame this as a hypothesis rather than a definitive claim, the idea has nonetheless captured public imagination and stirred controversy within the scientific community. The most significant anomaly associated with 3I/Atlas is its non-gravitational acceleration. Objects moving through space typically follow paths dictated by gravity alone, unless acted upon by another force. In comets, such acceleration is usually explained by outgassing. As the comet approaches the sun, heat causes volatile ices to sublimate, releasing jets of gas and dust that act like tiny thrusters. This effect has been observed many times and is well understood. However, in the case of 3I/Atlas, the observed acceleration appears unusually strong relative to the absence of visible signs of outgassing. Astronomers would normally expect a comet experiencing such dramatic thrust to produce a conspicuous coma or tail, shedding large amounts of material into space. Yet, so far, observations have not revealed the massive plume of debris that standard comet models would predict. This apparent mismatch between acceleration and visible mass loss is a central point in Loeb's argument. He notes that if the object were undergoing the level of outgassing required to explain its motion, it should lose a significant fraction of its mass over a relatively short time. The absence of such evidence raises questions about whether a different mechanism might be at work. Loeb has proposed that, in addition to exotic natural explanations, such as hydrogen or nitrogen ice outgassing, ideas previously suggested for Oumuamua, one cannot completely rule out the possibility of an artificial origin. In his view, science advances not only by confirming familiar models, but also by rigorously testing unconventional hypotheses, especially when dealing with unprecedented phenomena. Another layer of intrigue comes from the object's color. Astronomical color measurements provide important clues about composition and physical processes. Initially, 3I/Atlas appeared reddish, consistent with many small bodies coated in organic-rich material altered by cosmic radiation. Later observations suggested a shift toward green, and more recent data from sun-orbiting spacecraft indicated that the object had become distinctly bluer than the sun. Such a pronounced blue color is rare and unexpected, particularly for a body thought to be dominated by dust and ice. In comets, bluish hues can arise from certain gases, such as ionized carbon monoxide, glowing under solar radiation. However, the rapid and seemingly inconsistent changes in color observed for 3I/Atlas complicate this explanation. Loeb has seized upon this color shift as another potential clue. While acknowledging that unusual cometary chemistry could, in principle, account for the observations, he has also speculated that an artificial light source or a hot engine could produce a similar effect. This suggestion does not imply certainty, but rather highlights the difficulty of reconciling all the data within a single, conventional framework. Critics argue that invoking alien technology is unnecessary and violates the principle of parsimony, often summarized as Occam's razor. They contend that nature has repeatedly surprised scientists with phenomena that initially seemed inexplicable, only to later be understood through improved observations and models. The observational limitations surrounding 3I/Atlas further complicate the issue. Due to Earth's position on the opposite side of the Sun during a critical phase of the object trajectory, ground-based telescopes were unable to collect continuous, high-resolution data. This gap in coverage has left scientists reliant on indirect measurements and observations from spacecraft positioned elsewhere in the solar system. Notably, several Sun-orbiting probes were able to observe the object during this period, providing valuable but still limited data. A paper from the U.S. Naval Research Laboratory reported rapid brightening and the unexpected blue coloration, findings that have fueled further debate rather than settled it. In the broader context of astronomy, the controversy over 3I/Atlas reflects a deeper tension between skepticism and curiosity. Interstellar objects are, by definition, rare visitors, and each one may carry the imprint of a different stellar environment with unfamiliar physical and chemical conditions. The small sample size, only 3 confirmed detections so far, makes it difficult to establish what is normal for such objects. What appears anomalous may simply be a consequence of our limited experience. From this perspective, 3I/Atlas may be an entirely natural object that challenges existing comet models, prompting refinements rather than radical reinterpretations. At the same time, Loeb's arguments touch on a philosophical question that extends beyond this single object. How open should science be to the possibility of extraterrestrial technology? Loeb argues that dismissing such possibilities outright without careful analysis could reflect an unscientific bias rather than healthy skepticism. He often draws parallels to historical cases in which unconventional ideas were initially ridiculed but later accepted once evidence accumulated. Critics respond that extraordinary claims require extraordinary evidence, and that no observation associated with 3I/Atlas currently meets that standard. They emphasize that speculative interpretations risk misleading the public and undermining trust in science, if not clearly distinguished from established conclusions. From NASA's perspective, the comet explanation remains the most plausible. Even if 3I/Atlas does not fit neatly into existing categories, comets are known to be diverse and sometimes surprising. Variations in composition, structure, and activity can lead to behaviors that deviate from textbook expectations. For example, some comets may release gas in forms that are difficult to detect, or their dust production may be suppressed by surface properties. Additionally, observational biases and uncertainties can exaggerate apparent anomalies, especially when data are sparse or indirect. As 3I/Atlas continues its journey through the solar system and eventually back into interstellar space, astronomers hope to gather more data that can clarify its nature. Future observations, improved modeling, and comparisons with other interstellar visitors may help determine whether its acceleration and color changes can be fully explained by natural processes. Even if the alien engine hypothesis ultimately proves unnecessary, the debate itself has value. It forces scientists to scrutinize assumptions, improve observational strategies, and think more broadly about what kinds of objects may exist in the galaxy. In the end, the story of 3I/Atlas is less about proving or disproving the existence of alien technology and more about how science confronts the unknown. It illustrates the excitement and uncertainty that arise when humanity encounters something genuinely unfamiliar, arriving from beyond the boundaries of our solar system. Whether 3I/Atlas is an unusual comet shaped by alien stellar chemistry or something even stranger, it serves as a reminder that the universe is far more diverse than our current models can fully capture. As our detection capabilities improve and more interstellar objects are discovered, today's mysteries may become tomorrow's case studies, transforming speculation into understanding and, perhaps, revealing surprises that no one has yet imagined.